Hey everybody, Trey here. Welcome back to another video. Today we're going to take a trip out west and do a case study on the most prolific tornado outbreak to ever occur west of the Rockies. And that took place across parts of Arizona on October 6, 2010. This was kind of a two-day event. The first day, October 5th, 2010, we had a very potent severe weather setup across the central and south central Arizona deserts, including this supercell that you see pictured here, that dropped baseball-sized hail across parts of the Phoenix metro area. Then things kind of quieted down, and then we had the main portion of the tornado outbreak that occurred on the morning of October 6th. So pretty interesting event, not something that happens a whole heck of a lot out in the desert southwest, but kind of one of those things where all the parameters kind of lined up for a big severe weather setup, and we'll discuss that here in this case study. So let's go ahead and get started here. This is the SPC outlook from October 5th, 2010. The morning outlook showed a slight risk here, 2% tornado probabilities extending from the Mexico-Arizona border up through about the Las Vegas, Nevada area, with a damaging wind and hail threat as well. Pretty potent setup here across the region. So this is going to be, we'll start off with the 500 millibar chart here. And you can see this big old trough spinning out here across the west coast, kind of cut off out here. So I'm going to go back here and look at the 12Z chart here from the 5th. So this helps us see things a little bit better, but very well-defined closed low here at 500 millibars, enhanced flow rotating around the base of that closed low. And we can see several different short waves around here. We'll go down to 700 millibars. You can see one out here extending back kind of in the Los Angeles area, extending out into the Pacific. One down here approaching the Baja California Peninsula. Then kind of one right in here across northern Arizona. That kind of stays in place, so I believe that is somewhat terrain-enhanced feature perhaps. Because that kind of stays the same here throughout the entirety of the event. But several different short waves rotating around the main sort of closed low here across the west coast. This is very potent sort of setup, and we'll advance here a little bit, and you can see this closed low just kind of sits there throughout the day on October 5th. We have this nice belt of flow here. This is at 21Z, and for this video, remember that UTC time is it's going to be UTC minus 7 hours for Arizona, so this would be 1400 hours or 2 p.m. Unlike the Plains case studies we do often, where it's UTC minus 5, it's going to be minus 7 here for the desert southwest. So just keep that in mind as we go through this video here. But this trough just kind of sits here across Southern California here, belt of enhanced flow across the desert southwest, 60, 65 knots here across much of Arizona. And it just kind of sat there throughout the day, and those multiple little short waves kind of rotated through the region throughout the afternoon and evening hours across Arizona. We'll take a look at satellite here. Unfortunately, don't have a zoomed-in view of the satellite here, but you can really see that swirl in the clouds here. This is visible satellite on the morning of Tuesday, October 5th, 2010. You can already see very convective look to the skies out here across Arizona. Some patchy kind of cumulus clouds down here across southern Arizona. So it looks like some storms ongoing here across northern Arizona as well. And that would kind of hamper things for the northern half of the state. The clouds kind of remained throughout the day across the northern half of the state. You can see some patchy breaks, but it's much thicker clouds up here across the northern portion of the state. Much more convective looking sky down here, kind of pockmarked cumulus here. And we actually had storm development pretty early on in the day on October 5th. So let's go ahead and look at some surface maps. Again, this is back in 2010, so we don't have our normal sort of surface charts that we look at here. So I had to kind of make up things, was able to pull some surface maps from the Plymouth State Weather Center, great resource for weather data. So this is what the surface pattern looked like at 12Z on October 5th. This was 5 a.m. on October 5th. So you can see we have a nice fetch of 60s dew points here across southern Arizona, low 60s dew points here, extending all the way up to the Phoenix metro area, with some low to mid 50s up here approaching the Mogollon Rim region up in here. That's very high moisture this time of year in Arizona. Usually we see very dry air. But of course, as we know, as we get into higher terrain, the higher the dew point, it's going to be enhanced a little bit by that terrain. So for example, a 50 dew point up here in the Mogollon Rim region is going to be, closer to maybe a 60-degree dew point out here on the lower deserts. So very seasonably high moisture content here in place, and it kind of stayed that way throughout the day. We didn't have a ton of vertical mixing. We do see dew points go down just a little bit here. This is at 20Z, so 1 p.m. October 5th here. And you can see this. We had some convection ongoing. I'll go to 12 p.m., 12 noon here. 86 over 58 here at Phoenix, so definitely a little bit of mixing, but we do have a nice fetch of southerly flow here, kind of maintaining that moisture across the south central Arizona deserts here. Some mixing here at Tucson, dew point down to 55, but that's still seasonably high for this time of year across Arizona. You can see up here much cooler profiles here, only warming into the 50s here, and that's not unusual for the northern Arizona region. You're obviously going to be much cooler up here in the mountains than you are in the lower deserts. But those clouds were sticking around, so the instability axis was going to remain sort of here down to the south across the region. So we go ahead a few hours here. This is at 21Z, so early afternoon. And we can pick out a couple of interesting features that we don't often see in the desert southwest. So you can see here westerly winds out here across the Colorado River Valley, Southern California. We have mostly easterly or southerly flow here to the east. So we have a convergence boundary here. And notice the thermodynamic characteristics across this boundary. Temperatures in the 80s out here across far southeast California. A little bit cooler out here into the south central Arizona deserts. Very dry air behind here. Dew points in the 30s here across Southern California. Dew points in the 50s and 60s here across the south central Arizona deserts. Well, where do we often see that? We often see that in the plains in the form of a dry line. So we actually had somewhat of a dry line feature set up here across western Arizona. Not something you see out here that often. A little bit of a surface low up in here. You can see kind of the cyclonic curvature here. Northerly winds here at Las Vegas, southern Nevada, southern Utah, more of an easterly flow. Then here along the northern Arizona kind of Flagstaff area, southerly winds. So kind of some sort of circulation here. So a little bit of a surface low there, kind of near the Kingman, Arizona area there up near the Nevada border. Then back out here, we do see somewhat of a cold front here. You can see temperatures in the 80s here across far southeast California, dropping a little bit to the low to mid 70s here across southern California. And we do see a wind shift here. Westerly winds out here across the region here, veering, backing a little bit here as you go to southeast California. So a very kind of weaker sort of cold front out here across Southern California. Again, not something we see a whole lot out here in the desert southwest. So we had a nice boundary in play here for storms to fire on here across south central Arizona in the early afternoon hours. And that would kind of stay in place here through the early afternoon into the evening hours across Arizona. So let's go ahead and go to the radar here. So this is going to be our kind of broader view radar here. So this is starting at 15Z. So this is at 8 a.m. You can see very early on, given the amount of flow and those just multiple shortwaves rotating through the region, we had storm development out here in far northwest Mexico here very early on in the morning, about 9 a.m. These became strong fairly quickly as we went on through the morning hours. You can see some enhanced reflectivity there, and also a very sort of supercellular shape, nice sort of hook echo there with this storm south of Gila Bend, which is right about there. Of course, Phoenix is right in here. The Phoenix radar right out here. So Phoenix is going to be right in here. And all this out here is going to be noise. You'll see that stay throughout this radar image and not really move. That's how you know it's noise. So we go on through the morning hours here. Storm development becomes more numerous here across the southern Arizona deserts, and we do get these storms amid the very high shear values here to attain supercell characteristics. You can kind of see the sort of kidney bean shapes on some of these storms here. So there was a lot of shear in play on this day. Storms firing along that dry line and kind of out ahead out here across south central Arizona. We continue on throughout the afternoon, and we get our first major storm to impact the Phoenix area about just after lunchtime here across western portions of the Phoenix metro area. You can see a very nice supercell here with hook echo, high DBZ values here in the middle. This drops some large hail across western Phoenix, the western Phoenix metro area, with multiple other supercells ongoing out here across the south central Arizona deserts. So we continue to move on here, and this early storm here, you can see very wrapped up storm there. Temperature dew point spread's a little bit high for tornado potential, but it was dropping large hail. But you can see this fine line here emanating from these storm complex here. This was an outflow boundary that would continue to push south throughout the afternoon, and storms that were firing up in southern Arizona were interacting with this boundary, becoming strong very quickly, and then kind of becoming undercut before that boundary kind of washed out a little bit in the afternoon hours. So we go forward here a little bit, continue to get storms out here, move off into the northern Arizona. You can see very quickly that they weaken very quickly as they went off into the higher terrain of northern Arizona. We just did not have the thermodynamic characteristics there for sustained, robust updrafts that far north. Continued convection down there. We just have an immense amount of forcing here across the region with this trough just kind of sitting there. These multiple little short waves rotating throughout the day. You can see one here. You can see one kind of in here. So just multiple little rounds of these little engines, little short waves that moved through and helped initiate storms across Arizona on the afternoon and evening of the 5th. So let's go ahead and see here. They issue the first mesoscale discussion here at just after lunchtime, 12:44 p.m. across south central Arizona. Isolated supercells with sporadic large hail and perhaps a brief or weak tornado. The issue with the tornado threat was that as we said, the LCLs were going to be a little bit high. So this is pre-convective here, 19Z. So Phoenix 86/58. That is pretty darn high. 28-degree temperature dew point spreads are a little bit high. A little bit farther south, we see 82/61, 70/50 here with thunderstorms in the area. So we were close. We were close. 84/63, very, very close here. As far as tornado potential goes, we were just a little bit high as far as that went. But later on, you can see, going backwards here. Later on, you can see that the convection actually kind of helped things out later on, 79/58, 79/64 here across south central Arizona. So the rain-cooled air from those storms earlier helped bring the LCLs down a little bit. And that's why we saw in this picture here, it's not a super high storm base here, at least as far as Phoenix goes. Usually you're talking about astronomically high cloud bases here, but this is not astronomically high. Fairly low LCLs here. We take a look at our mesoanalysis data. Let's go ahead and go back to our LCL height here. And we'll take a look here across the region. You can see 19Z, we're really not all that high. The 2000 line is kind of right in here. It's kind of the rule of thumb as far as tornado potential goes. Anything above 2,000 meters above ground level starts to get a little bit dicey for tornado formation. But you can see we're just kind of straddling that line. So nothing out of the ordinary for tornado formation here. We don't see these kind of low LCLs a lot in Arizona. So there was definitely a brief tornado threat. I'm going to pull up the wind profilers here. Unfortunately, we don't have soundings here. I'm also going to bring up the Tucson and Flagstaff soundings here. We'll start off with Tucson here. So this was 12Z on the 5th. Something interesting to note here, this is a very saturated profile. So for this time of year, this was very anomalously high moisture throughout the entire column. Very, very saturated profile here. That's why you can see the possible hazard type was flash flood. And actually, the SPC downgraded the severe probabilities at the 1630 outlook. They downgraded it back here. Back then, we had the C text, which is now the marginal category. But they took away the 15% hail and wind threats, citing a only modestly unstable air mass across the region and implying that the focus would be more toward a heavy rain threat. And just looking at the morning soundings, you could kind of see that was the case. Very saturated profile here at Tucson. Kind of a wonky, elongated hodograph, a little bit of turning in the low levels. Lots of shear in play, 35 knots or so of effective shear. We move on to 0Z. We kind of skip a little bit. Unfortunately, Phoenix did not release soundings on both the 5th and the 6th, so we're missing a little bit of data there. That's why I have the Phoenix vertical wind profiles here in the back. You can see that kind of stays the case throughout the day. We do get quite a bit of mixing here at Tucson, 77/52, kind of that inverted V profile here in the afternoon. But overall, a very saturated profile here. So this would imply more of a sort of heavy rain threat. But across the south central Arizona deserts, we did destabilize pretty nicely. We'll take a look at our mesoscale analysis here. Let's go to mixed layer CAPE. And you can see that we do destabilize quite a bit throughout the afternoon. We do get about 1,000 joules per kilogram here across the south central Arizona desert. So nothing to scoff at by any means. 19Z, this is about midday. We already have 1,000 joules per kilogram of CAPE. That's very, very high. And these waves were timed nicely. This kind of secondary wave here was timed very nicely with our diurnal cycle. So peak heating occurring. We have a nice little shortwave rotating through here. So right ahead of that, we're going to get storm development. You can see that kind of shortwave that kind of maintains itself across northern Arizona. Perhaps something to do with that surface low as well. Terrain, kind of unsure why that kind of shortwave looking thing stays in that place throughout the entirety of the event. But nonetheless, we have nice shortwaves rotating through, and this one was timed very nicely with the afternoon convection. So this was the wind profile at Phoenix, the vertical wind profile from the Phoenix radar, the VAD here throughout the day. This is going to be 12Z. So you can see in the morning we have nice turning in the low levels, fairly strong winds near the surface here, 20 knots or so here. That's pretty strong for Arizona. Not a whole lot of change in wind speed as we go up through the environment. We're a little bit removed here on the morning of the 5th from that actual trough. We do have some nice turning in the low levels. As we go through the day here, you can see by 15Z, the morning hours, and then again by 18Z, very nice curvature here in the low levels, something we see in the plains a lot. Nice veering wind profile with height. Fairly unidirectional above the surface, but nice veering here. Would support supercells for sure. You know, you could imagine that the hodograph would look something like this, roughly some turning in the low levels, and not a whole lot of movement here in the mid levels, not a ton of mid-level shear, but very strong low-level shear. Then by 22Z, we're missing some data here, but you can see at 2049, winds at the surface had actually veered to southwesterly, perhaps at because of the outflow boundary that emanated from those storms earlier on. Those winds pushed out from the northwest, and then they probably flipped around a little bit to southwest as we continue to get that strong surface flow. That surface flow up in northwest Arizona kind of maintain that southerly flow. So these were starting to flip around again by 2021, 22Z here. You can see the shear has increased a little bit. Winds aloft had increased a little bit here. So some stronger wind shear moving in. Then by 23 to 0Z, the time that the Phoenix storm, that supercell near Phoenix was ongoing, strong winds aloft, fairly unidirectional profile here. You can see that the wind direction doesn't change hardly at all here as you go up throughout the profile. Wind speed does somewhat, so mid-level shear, mid and upper level shear, not a whole lot to speak of, but stronger winds aloft, nice backing of the winds at the surface, so we had a nice profile here. Definitely favorable for supercells as we went through the afternoon hours on the 5th. So again, this was the sounding at Tucson. Again, I think instability was a little bit underdone here at Tucson. We were a little bit higher than what that was showing. And let me show you Flagstaff here as well. So this was it between 12 and 0Z. You just see there's not a whole lot of instability to speak of. A little bit here in the low levels, but just not a whole lot of instability to speak of. A lot drier air aloft here at Flagstaff. You can see the separation between the green profile, the dew point profile, and the red temperature profile here. Lots of dry air aloft here at Flagstaff, whereas down south we were a lot more moist. But you can see this hodograph, very, very favorable for supercells. You can see 0 to 1 SRH of over 300 meters squared per second squared. Very long, elongated hodographs here with some curvature in the low levels here at Flagstaff. So thinking we were somewhere in the middle here between the Flagstaff profile and the Tucson profile. Not totally saturated at Phoenix. A little bit more instability than maybe sounding suggested at Tucson. And kind of somewhere in between that wind profile there at Tucson, which was a little bit wonky, to something that looked like this at Flagstaff. Very highly sheared profile. So we go to the afternoon hours. Let me go back to our broad view here. Continued storm development throughout the afternoon. Kind of across that I-8 corridor, multiple supercells here across the East Valley now. You can see nice supercell there moving across the eastern portions of the Phoenix metro area. This was about 5 p.m. And then we got continued storm development here Across kind of the I-8 corridor here, up just to the south of the Phoenix metro area, these quickly became supercells. And actually, the SPC did reinstate that slight risk at the next afternoon outlook there. So we go on through the afternoon, multiple kind of clusters of storms here fire with very strong winds and large hail. We'll zoom in here to the southwest, to the kind of Phoenix metro area. So Phoenix is right in here, downtown Phoenix right here, the Phoenix radar is right in here. So you can see multiple strong storms, strong to severe storms ongoing here. They very quickly take on supercell characteristics. This was our storm to watch here. Kind of clustered here. The mode is a little bit messy. We did have quite a bit of forcing with this event, so we did kind of maintain discrete supercells, kind of more of a clustered mode, kind of somewhere in between here. But we see that this supercell, as it moves into Phoenix, kind of stays isolated here. Very strong core. Again, this is just noise right in here. This is our supercell to watch right in here. Multiple supercells here entering the southern and western portions of the valley. So very strong storm here. You can see very large hail. And that maintains kind of a discrete nature here as it moves off into the West Valley, just on the western side of Phoenix and toward Glendale and Peoria out here on the west side of the valley. Very high reflectivity out here. So indicative of a large quantity of hail, and this was very strong, very large hail as well. So this storm continued off into the Phoenix metro area, the northwest portions of the valley, and then things kind of died down as we went into the evening hours after towards sunset. And this storm was not a storm to scoff at by any means. This was some of the hail that it produced. Again, just crazy structure for Arizona standards here. Just ridiculous structure. Pancake stack there with very impressive structure there. And it dropped some large hail. I'll play this with the volume on. This is kind of the most famous video from this storm. This was at Cactus and 59th, so parts of the West Valley here, taking a beating from some hail. Just absolutely crazy footage there. And some more footage here. You can see baseballs falling down in Arizona, no less. So very potent storm system that was one of the costliest hailstorms ever in Arizona, especially the Phoenix metro area. All right, now let's take a look at what transpired the next morning, October 6th. And this is the map of all the tracks of the tornadoes that occurred across northern Arizona on the 6th. 11 tornadoes in total, including several that took a very similar track here just to the west of Flagstaff, kind of bearing down on the town of Belmont, which is where the National Weather Service Flagstaff office is located. And I want to bring your attention to this website here, Tornado Talk. They do a great job of going through different tornado events and really collating all the information you can find on these events. And so I'm going to use their page quite a bit here for this discussion here. Just wanted to bring to your attention this page. If you want to learn more about this outbreak kind of in a concise manner, take a look at all the different pictures and videos there are out there on this outbreak. Take a look at the link here and visit this website. So again, this was the path of the tracks of all the tornadoes on the morning of the 6th. Multiple tornadoes here. The first one here was this one that occurred near Blue Ridge, very close to the Flagstaff radar site, just after midnight on the 6th. And let's kind of set the stage here. This was the 6Z convective outlook from the SPC. You can see here they had downgraded to a C text here for October 6th. Still a 2% tornado threat, 5% hail, and damaging wind threats here. And they were kind of a little bit concerned, at least from a severe weather perspective, that there wasn't going to be as much activity as there was on the 5th. And the reason here, it was a twofold reason. You can see here on the radar image, this is at 6Z, so just before midnight here on the 5th. You can see quite a bit of rain here across into the north of I-40 here. This was expected to kind of keep instability at bay here. Even as the trough moved in, it was kind of expected to keep instability at bay and kind of temper the threat here farther north. Down to the south, you can see it's pretty clear, but we were behind the main shortwave, the main kind of energy, and it was going to be pretty mistimed with as far as the diurnal cycle went. So that was kind of a twofold reason why they were kind of pulling back on severe probabilities here for the 6th. Kind of sapped instability up north from the ongoing rain and storms, and kind of subsidence in the wake of the shortwave, sinking motion in the wake of that shortwave that initiated the storms here across the south central Arizona deserts on the 5th. So let's kind of take a look here at our environment here. So this is our 500 millibar flow, and you can see that 500 millibar closed low just continue to sit there. We do see it advances maybe a hair to the east and kind of amplifies just a little bit here as we go into the overnight hours and early morning hours of the 6th. But you can see a nice, well-developed shortwave here. This is at 5Z just before midnight on the 5th. Well-developed shortwave kind of swinging around here into Arizona. Now, this is going to be very poorly timed. This was expected to impact the region between about 12 and 15Z, so about 5 to 8 a.m. Very mistimed as far as the diurnal cycle goes. Oftentimes when we're talking about big tornado events, it's often timed in kind of the late afternoon hours when peak heating is occurring, or maximum heating from the sun is occurring. Well, this was going to occur in the early morning hours when it was still dark. So there wasn't expected to be as much severe threat as there was on the 5th. Let's go down to 700 millibars here and take a look at the 700 millibar map. We can really pick out the shortwaves here. This was at midnight here on the 7th. Very, very well-defined shortwave here, rotating into the Baja. You can kind of call this one as well. That may be kind of the broader scale sort of trough with these little kind of embedded shortwaves here moving through. One maybe right in here across south central Arizona. So there were several little shortwaves moving through. Our main shortwave, though, had moved off toward the north, and thus we were seeing some subsidence here on the backside of that, and that's why SPC kind of pulled back severe probs for the 6th. We continue through, and you can see it's a little bit difficult to see here. So I'm going to go to a product here, differential vorticity advection. And this kind of shows us just for basic terms, vorticity is going to be the spin in the atmosphere, and vorticity advection is going to be the transport of that spin. So the warmer colors, the yellows, oranges, and reds, are going to be where vorticity is at its strongest. So kind of spin within that trough where the spin is sort of maximized. And ahead of vorticity maxima, we get rising motion and greater potential for thunderstorms, all else equal. So we go through the afternoon hours here. You can see that initial vorticity max rotating through western Arizona here, right here. So that was going to rotate off toward the north and leave Arizona in a little bit of subsidence, kind of in between this lobe down here, which is going to be our next lobe, and this original lobe that initiated the storms on the 5th. We were kind of in a lull here in central and northern Arizona here between these two waves. Well, we go forward here, and you can see this vorticity max really start to spin through, arriving in the region about 10Z or so. You can see the vorticity max right in here. So right out ahead of these would be your favored region for storm development. But look at this, it's 10Z, so 3 a.m. So not something you often see is a lot of storms associated with these mistimed sort of waves. But here's the thing with this trough. Take a look at this 500 millibar trough. We see very cold air aloft here near the center of this trough impinging into the region. We see kind of minus 18 to minus 20 degrees Celsius here at the core of this trough. So very cold air at the center of this trough. And that's kind of what helped destabilize the atmosphere, even though we were not dealing with any solar heating at these early morning hours. Let me go to the Flagstaff sounding here. This is the Flagstaff sounding at 12Z. Very interesting here. So we'll show you here what happened. So this was the 0Z sounding from the 6th, so the evening of the 5th. You can see very meager instability here. Some drier air aloft, saturated sort of low levels, very moist low levels. And then this is what happened by 5 a.m. on the 6th, 12Z sounding on the 6th. You can see what happened. We had destabilized quite a bit, almost 500 joules per kilogram of mixed layer CAPE. And you can see a lot of that is concentrated here in the low level, 0 to 3 kilometer CAPE of 151. We talk about 3 CAPE very often on this channel. It's a very efficient mechanism in tornadogenesis processes because when you have lots of spin near the surface and you have very strong instability in the lowest levels of the atmosphere, any spin near the surface is going to be stretched very efficiently and that can aid in the tornado genesis processes. And we do have quite a bit of instability here compared to what we had the previous day, even though 500 joules per kilogram may not sound like a lot, but it's plenty with this kind of shear. Take a look at this profile here. Very strong low-level shear here. You can see very strong veering of the winds with height. We'll take a look at the surface map here. We had easterly winds here at the surface, veering to pretty much southerly winds, meridional flow throughout the entire column. So fairly unidirectional profile, but very strong turning in the lowest levels with height. So you don't see this very often in Arizona at all. Fairly weak mid-level shear. You can see the direction is not changing at all. The speed is changing a little bit. So fairly weak mid-level shear, but very strong low-level shear. And this is akin to profiles that we often see in the southeast. I'm going to pull up a sounding here from a tornado event that occurred near Yazoo City, Mississippi on April 24th, 2010. I'm going to have the Flagstaff photograph here on the right. So this was a profile associated with a very significant tornado that ravaged the town of Yazoo City, Mississippi on April 24th, 2010. So take a look at this profile here. Of course, we don't have as meridional flow, but you can see some very strong similarities here in the profiles. You can see quite a bit of turning here in the low levels. Lots, kind of, at first glance, it might not seem like your big sort of curving photographs that you often see in the southeast, but very strong low-level shear. Zero surface winds here, just above 10 knots out of the south, veering to southeasterly winds at almost 50 knots, almost 60 knots here at 1 kilometer. So very, very strong low-level shear, 52 knots of 0 to 1 kilometer shear here on this Yazoo City event. We have 38 knots, almost 40 knots of 0 to 1 kilometer shear for this October 6th event. Very similar photograph here, though. Very strong shear in the first kilometer or so. Fairly weak mid-level shear. You can see kind of the 3, 4, 5, 6, 7, 8 kilometer levels kind of piled on top of each other here. That's kind of what we're seeing here as well. And you can see a fairly unidirectional profile above that sort of low-level turning here. The direction of the winds doesn't change very much, although the speed might change a little bit throughout the profile. So we have very kind of weak mid-level shear here, atop very strong low-level shear. And these kinds of profiles are often associated with kind of long-track mesocyclones that kind of will keep regenerating and keep persisting for quite a while. And when the storm kind of loses its mesocyclone, the storm doesn't really stay together all that much. So these storms in these profiles are very efficient mesocyclone producers and tornado producers as well, with significant tornado potential as well. Of course, in this environment, we have quite a bit more instability here, but with this kind of shear, it doesn't take that much instability. We just need robust updrafts, and this was going to be a profile that would support robust updrafts. Even though we only have 500 joules per kilogram of CAPE, very concentrated here in the lowest levels, these were going to be low top storms, able to take advantage very efficiently of this very strong low-level shear, almost 300 meters squared per second squared of effective SRH here. Not something you see in Arizona very often. And this sounding was taken, this was an observed sounding from Flagstaff, just about 10-15 miles east of, this was actually taken in Belmont, just ahead of these tornadic storms that occurred about 6 a.m. on the 6th. So this was a very representative profile of what the environment looked like. Yes, we're a little cool at the surface, maybe 46 degrees here at the surface. And let's go ahead and look at the surface map here. I'm going to look at the surface map here. So let's go ahead and zoom through these. So we'll go here, we'll go toward midnight here. You can see we've maintained the 50s dew points here up into the Mogollon Rim region. 60s dew points down here into south central Arizona, but again we have that vorticity max rotating through. South central Arizona going to be on the backside of that second vorticity max near Baja, California, that would rotate through in the early morning hours, and thus subsidence here and storm development was unlikely farther south here. Right ahead of this vorticity maximum, dew points even in the 40s here at Flagstaff at 7Z, so midnight here. That is not that bad of a profile if we're talking about elevated terrain. Flagstaff is very, very high up, about a mile high or more in the air above sea level. So 43 dew point at Flagstaff is very much like a dew point in the low to mid 50s here, with 50s dew points out here into the Mogollon Rim region here, low 50s here. Very high dew points at this high of terrain. So once again, And something to note here as well, we'll take a look at our 850s here. This was not an event where we're seeing a very strong low-level jet like we see in the plains. It's not one of those systems where we have a very strong surface low to deal with. So we have our big sort of cyclonic circulation out here centered across California. We don't really have a well-defined surface low that is going to help back those winds and initiate a mass response that would increase the low-level jet here across Arizona. You can see that there is some low-level jet there, upwards of 15 knots or so across south central into kind of northwestern Arizona there, but not your 30, 40, 50, 60 knot low-level jet at 1 kilometer that you'd see on the 850 millibar map for your typical kind of plains tornado event. So this was very much driven by terrain and very, very strong shear amid very strong low-level instability. Very much like a cold core type event that you see kind of in the Midwest, really any time of the year where you have strong low-level instability. Low-level shear might be weaker, but if there's spin near the surface near some sort of boundary, you get very rapid, very strong upward motion that helps stretch vorticity near the surface. So let's go back to our radar here and take a look. So we had kind of a quiet look here after that October 5th activity. Then we had quick development of storms here just about midnight here, even as far south as the Phoenix metro area. Let me set the stage here. Flagstaff is right here. Belmont is right here. We're going to mention Belmont several times in the upcoming minutes here. Phoenix is down in here. This is Interstate 17 from Phoenix to Flagstaff. The Flagstaff radar is right in here. So you can see storm development ahead of that vorticity max swinging through from the Baja California Peninsula was allowing storms to develop here with the aid of the higher terrain here, upslope flow, southerly flow up this higher terrain here, this mountainous terrain here, helped aid in the lift. Of course, as we know, if we have air that runs into a mountain, it's got to go up, and rising motion is favorable for storm development. So we had lots of storms starting to develop here in the early morning hours of October 6th, and you can see they take on very supercellular characteristics very quickly, particularly these storms right here just southwest of the Flagstaff radar. And let me zoom in here to the Flagstaff radar here. And so you can see numerous storms here. Then we get our first tornado of the day that occurred near a location called Blue Ridge here near the Flagstaff radar. This storm actually tracked. We had a couple of supercells here. First one here. Second one, the main one here. You can see very well-defined hook echo here, likely producing a tornado at this point, just before 2 a.m. Mountain Standard Time here. Flagstaff radar right here. And a small tornado that occurred here near Blue Ridge was our first tornado of the day on the 6th. You can see it maintain itself, passing very close to the Flagstaff radar. And then the real show started to begin. We got more and more storm development here out across the kind of same areas, that higher terrain just north of Phoenix. After this kind of first batch went through, and we got storms to fire up just north of Phoenix, and they quickly became supercells here in the early morning hours, just between about 4 and 5 a.m. here, as they tracked toward the I-40 corridor near Flagstaff. So that sounding here was, as we saw, was very indicative of supercells, and these storms quickly went supercellular here. How often do you see this in Arizona? Supercells for sure here, producing tornadoes. You can see Flying Eagle supercell here, with kind of a donut hole there, with another one to the south. And in this kind of shear environment, with just enough instability to keep robust updrafts afloat, you got tornadoes to fire. We'll show you the velocity data here. And so this was our first tornado here, close to the Flagstaff radar. Very strong velocity couplet there. Once again, not something you see often in Arizona. And we got storms to fire, and they quickly became supercells here. You can see couplet after couplet here with these well-defined supercells here. One here right along I-17, one just to the north, and these would track off toward the north and approach the town of Belmont by 5 and 6 a.m. here. So you can see well-defined supercells here. Continuing, again, this is Flagstaff right in here. And we'll go here. So our first tornado was the Blue Ridge tornado, and produced quite a bit of damage near that Flagstaff radar site. Trees were snapped and flattened there. and that would only be a precursor of what was to come. So first tornado here from one of those supercells here, 17 miles south of Belmont, with about a 5-mile track. Once again, very quite a bit of tree damage here. Thankfully, these areas were fairly unpopulated. Then we got to the third tornado of the day, which impacted the town of Belmont directly. This was a long track tornado that was in progress for 26 miles. That is a long track tornado. You don't see that very often anywhere, let alone the desert Southwest. And this tornado was from this supercell here, occurred right about 6 a.m. or so. And we'll go back to the radar here. So it was from this supercell here. It was a long track supercell right in here that kind of perked up here just to this, well, to the south of Belmont. I mean, look at that. Arizona does not, you don't see that very often any time of the year in Arizona. Well-defined supercell, large hail as well. You can see the high DBZ there, at least large quantities of hail. And there was baseball-sized hail reported with these storms as well. Very well-defined hook echo. Perhaps a debris ball there at the tip of the hook, doing lots of tree damage there, lots of stuff for these tornadoes to pick up. Tracked through Belmont there, very near the National Weather Service office in Belmont. Let me show you the velocities here to show you that this was a strong tornado. This one, very strong tornado. This was the first Belmont tornado here. Very strong couplet. You can see that the outbounds here have been folded. They were so strong. So very strong winds there in that couplet. This was our second one here. Very strong signature. Very strong velocity signature here. Again, the outbound winds are folding. So if we go, these are, the highest red before they would fold is 70 knots. They would fold back to minus 70 here. And we're talking kind of darkish green. So, talking about maybe minus 20 or so here. So that's an extra 50 from 70. That's 120 knots of outbound winds here with these kind of modest greens. So about 40 knots, 50 knots or so of inbounds. That's a 170 knot rotational couplet there. Very, very strong signature. That's 195 miles per hour. So the radar was showing very significant velocity signatures with these supercells and these tornadoes. And this one would go very, very close to the National Weather Service office in Belmont. Actually went through a neighborhood in Belmont, causing some EF2 damage that was noted here in this neighborhood just in Belmont. This was, there's not a lot of pictures of the actual tornadoes in this event, but this was our second long track tornado here, path of 30 miles. And so that first tornado was the one that impacted Belmont from that initial supercell that we were tracking there. So these supercells here was that first 26-mile path. This one actually was the 30-mile path that continued on a very similar track to the first long track tornado. Again, lots of tree damage here, derailed some train cars here on the railroad near Belmont. And this was a photo of the Belmont tornado. This was from the AMS Facebook page, American Meteorological Society Facebook page. Take a look at this tornado here. Very wide tornado. This was a large tornado, and unfortunately, this was a video still, and I used to have the video from this tornado. Very strong tornado. You could see power flashes in the video, but this was a very stout tornado for Arizona, for anywhere, let alone Arizona. And this was rated EF2. Actually, this was upgraded to EF3, given the forest damage. You can see trees completely snapped here at the base here near Belmont. Just an incredible tornado for this area. Here's another photo of the tornado at 6:19 a.m. You can see at the very least a very large wall cloud here. Likely was just like that tornado. Just the picture of the tornado, not fully condensed, but lots of vortices here doing damage as it went through Belmont. This was from Camp Navajo. Very close to that initial picture that we showed there. So very, very strong tornado. You can see another picture here, a little bit of a wispy funnel there as well of one of the other tornadoes. This was the main tornado off to the right here. The stout wall cloud out here likely just cut off here on the edge of the picture with a little vortex right there that caused the train derailment here near Camp Navajo near Belmont. So very stout tornado here. So by 13Z, they had realized that they needed to put the slight risk back in. The SPC did, and they did 2% with a 15 hail and wind as supercells were ongoing by this point. And by 1630, they actually put in a 5% tornado risk area here as well. Take a look at the satellite image here. You can see that low spinning, continue to spin, and we just get very convective looking sky here. Numerous supercells ongoing here at this point on the morning of the 6th. And so let's take a look at the hodograph here as we go throughout the day. The main portion of the outbreak occurred in the early morning hours of the 6th. And after that, there wasn't a whole lot. So let's look at the reflectivity here. We continue supercell after supercell producing tornado after tornado here. And this would be about 8 a.m. Mountain Standard Time here. You can continue to see supercells here just pockmarked across the region. Discrete supercells at that too. And so we continue to get supercells here. But the event would eventually die down. We would not see a lot of tornadoes here. A couple of other tornadoes occurred from supercells down here across the region. This area would continue to stay under favorable defluence aloft. We'll take a look at the 500 millibar map quickly. Show you, actually we'll go to the 300 millibar map here. Show you that we were under very nice defluence aloft here. Whoops. Very nice defluence aloft. You can see the wind barbs going this way here across western Arizona, kind of going like this here across northeast Arizona. So lots of divergence or defluence aloft here in this region. And eventually the main sort of vorticity maximum would rotate through, and the best divergence, best parameters would move off to the north. Actually, the wind profile became a little bit more hostile as the event continued. So this is at 12Z on the 6th. You can see that hodograph here. This is from Tornado Archive here. This was reanalysis of the surface-based CAPE here, the color fill, and the hodographs here. So you can see very stout hodographs like what we were talking about earlier here. Very strong curvature in the low levels, fairly weak mid-level shear, fairly unidirectional profile above that. As we go forward here in time, you'll notice a couple of things here. Instability increases somewhat as we get some sunshine here through the morning hours, but we don't quite have as much curvature here on the here at 18Z, so 11 a.m. We've kind of lost our curvature here in the low level. Still very, very strong shear throughout the entire atmosphere, but we've kind of lost our low-level shear, and again, the main sort of forcing was moving off to the north by this point. Although we did have another significant tornado that occurred just about 18Z or so. Let me pull up the radar here. It occurred near Tuba City, Arizona, which was well to the north of Flagstaff here. And let me pull up the velocity here. All right, so this was our Tuba City storm. So we had, of course, the supercells moving through just west of Flagstaff, which is going to be out right in here. Flagstaff is here. Tuba City is somewhere kind of right in here, just to the north of Flagstaff. If you continue to the north, going north out of Flagstaff, you'd run into Tuba City up here. So we move on throughout the afternoon, and we get these kind of beans to form kind of ahead of the main sort of band of storms here out to the west. Kind of, if you could maybe call these prefrontal storms, these would be akin to prefrontal storms in the southeast. A couple of supercells out here moving to the north. And these intensified rapidly as they moved off toward the north. Again, we're getting a little bit farther away from the radar, so the coverage is not quite as good out here. But you can see they have that supercell shape here, a couple of supercells here near southeast of Tuba City. And we'll go to the velocity here, and these quickly attained rotation, strong rotation at that. Very strong couplet velocity signature here with this first one. And this actually produced EF3 damage by snapping a transmission tower. Let me go back here. Snapping a transmission tower near Tuba City. So not a very long track tornado, only a 4-mile path, but this was given an EF3 rating because it snapped this metal truss tower in half. That is reserved for strong to violent tornadoes. And of course, this is a very sparsely populated region, so we don't have other damage indicators. But this tornado easily could have been stronger than an EF3. It takes a lot to snap these metal transmission towers off. You can see it snapped in half here. just it takes immense power to do that. These things are pretty sturdy. And this was actually some video of this tornado, likely this tornado. Again, this was not filmed with a very good camera, but you can see this appears to be the Tuba City tornado. And you can see a very large tornado here. Very low cloud basis here. You can ascertain that from this video. Likely this was the Tuba City tornado. So very stout tornado here doing this kind of damage. And, you know, in this kind of profile, it doesn't take much to get this to happen. Very strong low-level instability, very strong low-level shear. This is something you see in the southeast a lot. If we had more instability, if this was favorably timed with peak heating and we had, you know, 1,000 to 1,500 joules per kilogram of CAPE, this would have been a significant tornado outbreak. We could have seen perhaps stronger tornadoes than what we saw in just this kind of meager thermodynamic profile. So pretty incredible event all around. And so one of the interesting things about this event is if you go on Google Earth now, you can still see some of the tracks from these tornadoes. So this is going to be the first Belmont tornado here. You can see the forest damage right along there. The trees still have not grown back in there. The first Belmont tornado, you can see the one of the initial tornadoes that day near Garjon Pass right here. You can see that kind of fine line there of tree damage. And this was our main long track Belmont tornado right in here. Just incredible that we can still see the scarring here of trees down, and this is, you know, 11 years later. This imagery was taken in 2021. 11 years later, we can still see the scars here from some of these tornadoes. So just a pretty incredible event, really for anywhere, but for Arizona to have this kind of event shows you that all it takes is for these impressive parameters to be in place and overlap, and you'll get some significant activity. We go throughout the day here on the 6th, and as we said, the tornado activity kind of wound down here pretty quickly as the wave kind of moved off. We had the best ingredients kind of move off toward the north. There was they did put the 5% in here, extending it farther to the south, actually citing the presence of a meso low here developing. Winds had actually kind of backed here and increased here across northeast Arizona. So there was some concern, and this was at 1 p.m., so about 20 Z here, that there would be an increase in tornado potential here across northeast Arizona. If we zoom back out here, we'll go to our zoomed out radar here. As we go through the day here, you can see not much else happens. We have very, tons of supercells here moving toward the Flagstaff area, the Belmont area, producing large hail and tornadoes. As we continue on throughout the day, you can see as they get up here toward far northern Arizona, they kind of die out here. Lots of just stratiform rain here, and these storms kind of die out here. I have a feeling that there was maybe a little bit less instability farther to the north, maybe still socked in with clouds. If we look at our satellite loop here, you can kind of see this was by 18Z. We have kind of this cirrus shield up here across far northern Arizona with a much more convective looking sky here with a lot more cumuliform clouds here to the south. So my guess is that instability was quite a bit lower here farther north with northern extent here, whereas to the south across northern Arizona, the I-40 corridor was kind of where it was maximized. Instability was maximized there. As little instability as there was, it was maximized there across kind of the I-40 corridor there in Arizona. So we had a few more tornadoes. The Tuba City tornado was the last major tornado of the day. We had a couple more occur after, a couple smaller tornadoes near Munns Park, near Flagstaff, and then one in Flagstaff. These were weaker tornadoes as the outbreak kind of wound down. If we look, let's go back to our surface map here. So you can see that the dew points kind of mix out here. We go from a 51 dew point here, likely at Holbrook. I believe that's Holbrook, Arizona. Went from 73 over 51 there at 18Z. Favorable moisture here for this region. And we drop quickly to a 39 degree dew point here. So mixing was definitely occurring. Perhaps the cold front kind of had swept through a little bit. So dew points had decreased here. Still, and up here near the Four Corners region, we still had kind of that cirrus shield in place. 73 over 38 here in Gallup, 40 degree dew point here far northwest New Mexico. So there was some mixing occurring, and the tornado threat never really materialized up in here. It was that early morning stuff, away from the favorable solar heating. Right ahead of that shortwave, we had just enough instability here to get a significant tornado outbreak to occur. All right, so a couple final things to wrap up here. Just kind of, we'll take another look at this. Just to kind of summarize here, October 6th, again, you have a very potent shortwave, very nice low of vorticity moving through. Doesn't have to be at peak heating. Sometimes all you need is some cold air aloft, just a little bit of destabilization in this kind of shear profile, 60, 65 knots of wind here at 500 millibars, very strong shear throughout the profile, a very strong low-level shear here, easterly winds along the Magellan Rim, veering with height, fairly unidirectional profile, fairly weak low-level shear, mid-level shear, something you see in the southeast. And if you get this profile with just a little bit of instability, especially if it's very much concentrated near the ground as it was here, 3 Cape above 150, you're going to see tornadoes. You're going to see tornadic storms if the moisture is there, and it was. Again, 46 dew point is not that bad if you're talking about higher terrain. So we had very strong low-level shear, very strong low-level instability. We'll go to our 0 to 3 kilometer Cape here. Let's move through here to the 6th. You can see overnight kind of builds in across northern Arizona. Then by the morning hours, builds in right at the time of that Tuba City tornado. We kind of get that maximum there, 150 right there, northern Arizona near Tuba City. Just on the north side of that was where that tornado occurred. So very strong low-level instability to help with that. It's kind of a cold core type event where you get low-level instability that's strong, helps stretch that spin near the surface into the vertical for tornado potential. Another question I had here was, why did these tornadoes kind of occur kind of in one area? The most significant tornadoes kind of occurred in this kind of region to the south of Belmont, and multiple tornadoes actually impacted Belmont here. So they often took this kind of line instead of you had kind of just pockmarked tornadoes from many of these supercells. Most of the tornadic activity occurred in kind of this corridor right in here. And why was that? And that's a tough question to answer. You could consider, so here's a topographical map here of Arizona. This is the San Francisco Peaks here. Flagstaff is right here. Belmont is right in here. This is the Magellan Rim. And this is Phoenix down in here. So you could argue maybe that we have a little bit of funneling of the winds, channeling of the winds here, maybe some sort of convergence zone in between the slightly higher elevations out here. The purple and yellows are your highest elevations. The greens and kind of the gold colors and orange are your lower elevations. So maybe you could have had some terrain influences here. It's hard to say. Perhaps that band of most favorable parameters kind of just lined up right near Flagstaff, and that's why we saw that. And as far as the Tuba City tornado goes, again, we were starting to see that vorticity max and the main parameters sort of shift away from the region by kind of lunchtime that day, but we still had a strong tornado to occur near Tuba City. And interestingly, it was kind of away from this kind of main band that was happening. Of course, the atmosphere was still kind of still very favorable for supercells, but again, our low-level shear profiles were getting a little bit worse with time. Well, we have a couple of hypotheses here. Number one is we have what's called the Magellan Rim Convergence Zone. This is a paper by David Blanchard, Flagstaff, NWS Flagstaff meteorologist here. And this is a convergence zone that often forms, oftentimes in the summer months when we have southwest flow transposed with southeast drainage flow. So if we look here on our topographical map, we have the Little Colorado River that flows through here. You can see lower elevation here. It's kind of the delta of the Little Colorado River Valley. If you've ever driven on I-40 east of Flagstaff, you'll know that it looks pretty plainsy out there. Gentle rolling hills, kind of your plains sort of grasses. It's got that plains look to it. Well, it's the delta of the Little Colorado River Valley. And what happens is at night we have drainage flow that will be channeled up the valley here, so out of the southeast. So when we have this southeast drainage flow, and you have kind of broad southwesterly flow kind of transposed with that, you get a convergence zone in this valley. And oftentimes we see a higher propensity for landspout tornadoes to occur up here when the Mogollon Rim convergence zone is going. When you have southwest flow aloft and you have southeast drainage flow in this valley. Well, Tuba City going to be up here kind of at the tip of this valley. And so this day we likely had southeast drainage flow. We have more southerly flow, but still kind of enough, I think, to get this convergence zone going, enough convergence there in the valley. So this helps to enhance vorticity, just like the Palmer Divide does in Colorado. You have southeasterly or easterly flow up the Palmer Divide, goes over the Palmer Divide, meets northwest flow out the Rockies, and you get a convergence zone there right near Denver. Same thing here. You get a convergence zone when you have southeast drainage flow up the valley and southwesterly flow aloft. Here we had, again, more southerly flow, but still enough, I think, to get the convergence zone going. So perhaps that could have helped with, we had strong, as we've talked about, low-level instability would help stretch that vorticity from the convergence zone into the vertical. And another thing I've hypothesized is that the San Francisco peaks may have something to do with this. This area tends to be a small sort of hotspot for tornadic activity. I've seen several tornado warnings up there near the Cameron, Gray Mountain, Tuba City sort of area over the past several years. There was one in 2012, in September 2012. There was one in maybe 2015. I can't remember exactly. But this area seems to be a little bit of a hotspot for tornadic activity. And one hypothesis is if we look at our surface map here, we'll go back to 18Z, about the time that the Tuba City tornado occurred. You can see we have kind of southerly to southeasterly flow here at the surface. Well, if you've ever looked in the Pacific near Catalina Island, sometimes what happens is if you have a landmass here, and if you have flow that's forced around it, what will happen is you will get spin-ups, little spin in the clouds as vorticity kind of is maximized there just on the lee side of that land feature. They're called von Karman vortex streets. If you ever pull up a satellite image, just Google von Karman vortex streets and you'll see just mind-bending satellite imagery of these little vortices ahead of a land feature after air is forced around it. So you have the San Francisco peaks here, which are very, very high, 12,000 feet, I believe. You have southerly flow heading toward the San Francisco peaks. Well, that air is forced around it. And what is going to happen on the lee side of that? Well, you have a maximum in vorticity just on the north side of the San Francisco peaks. Tuba City sits right in here. That may have helped increase the vorticity locally just to the north of the San Francisco peaks there and may have aided those supercells. Just a hypothesis. Again, it's not anything set in stone, just something that I've noticed over the past few years looking at lots of tornado cases from Arizona. It tends to be a hotspot up there, and I think that may be a reason why. So that'll wrap things up here. Again, this has been a long video, but this was a very, very interesting event. Again, take a look at the Tornado Talk page here if you want to learn more about this event. This was a pretty prolific event, one of the most prolific events west of the Rockies, the most prolific tornado event west of the Rockies. 11 tornadoes in all across Arizona with 2 EF3 tornadoes here, including some long track tornadoes, 30-mile paths. You just don't see that in Arizona ever. But just shows you all it takes is favorable ingredients, low-level instability, just enough instability, very, very strong shear, and if you have enough forcing, you can see effective helicities here, 100 to 200 here across the desert. If you have enough shear, if you have instability here, you see it, perk up to 300 there. All it takes is strong instability, strong shear to be co-located, and you'll get significant tornado outbreak. Doesn't matter where it is. It can happen in Arizona, as it happened here on October 5th and 6th, 2010. So with that, thanks for watching, and we will see you in the next video.